Hey everybody, in this video we're going to be finding trig ratios of angles that are defined by points, that is, coordinates of x and y. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now normally when we think of trig ratios as we're given an angle and we plug it in and we find the ratio, or we're given a right triangle. Well, here we're not given that. Here we're just given that an angle passes through 4, 3. And we want to find the 6 trig ratios for that. Well, let's get a picture going. So here's our point, 4, 3. And so we have this angle. And so this is our angle theta. We don't know what it is. And so how do we think of sine and cosine and tangent? Well, we like to think of them as parts of a right triangle. So where would a right triangle appear? Well, in this case, a right triangle would be here. This, and this, and this. And this would have a length of 4, this would have a length of 3, and the hypotenuse would have a length of 5. So that means in this case, sine of theta equals 3/5. Cosine of theta is going to be 4/5, and tangent of theta is going to be 3/4. So that means the other 3, cosecant, which pairs with sine, is the reciprocal, and that's 5/3. Secant of theta is going to be 5/4, and cotangent of theta is going to be 4/3. But this gets a little bit trickier when we get angles that are outside of the first quadrant, because here we can clearly see, all right, this is theta. And so we have to go back and think about this and say, all right, how can I just take this coordinate and get these ratios? Well, for sine, we take the 3, we take the y value. Now where did the 5 come from? That's the hypotenuse. So we just divide by that. But without a triangle, what's another way to think about it? Well, it's just the distance between the origin and this point. That's what the hypotenuse really is. So what we're doing is we're taking the y value and dividing by how far it is from the origin. And for cosine, well, we take the x value and divide by however far it is from the origin. And for tangent, we're just taking the y value and dividing by the x value. So let's apply this idea to an angle that's not from 0 to 90. Here, this angle is passing through the point -5, 3. So when we draw this, our point is over here. And the angle that we're concerned with is theta. And so what is going to be sine? Well, let's follow the example the way we did up there. Sine is going to be, let's see, 3 over, we need to stop for a second. We need to figure out what this distance is. So we would see this as this length right here and this length as 2 parts of a right triangle. And so this would be our hypotenuse. That's our distance. So let's see. -5 squared is 25, plus 3 squared is 34, and then we take the square root of that. And so we have sine of 3 over the square root of 34. Now, if you have a teacher that insists on rationalizing that, then you need to multiply this fraction by square root of 34 over square root of 34. And so you get 3 square root of 34 over 34 for your sine ratio. For cosine, we're just going to take the x value. It's -5 over square root of 34. And if we rationalize that one, that's going to be -5 square root of 34 over 34. And then tangent, that's going to be the y value, 3, divided by the x value, -5. So then the other 3 trig ratios, let's see, cosecant is going to be the reciprocal of sine. Now here's a reason why I want to also write out this form as well as this form, because I could take the reciprocal of this, but then I would have to re-rationalize the denominator. But if I take the reciprocal of this, I don't have to. It's just square root of 34 over 3. And then secant, if I take the reciprocal of this, I get square root of 34 over 5, or negative 5 rather. And then cotangent of theta is going to be negative 5/3. All right. Now in the next one, we're just given that the angle is xy. Well, we don't have any numbers to work with, so it's hard to picture. So it's hard to get a picture going, but I guess we could try. Let's see, x, y. So we have this side, we have this side. So this is x, this is y. Now what would be the hypotenuse? What would be that distance from the origin to the point? Well, it'd be square root of x squared plus y squared. And so this is us really generalizing the rule for finding the trig ratio at any point. And so if we follow our pattern, what would we do to find sine? Well, we take the y value and divide by the distance. So that'd be square root of x squared plus y squared for sine, whatever the y value is, whether it's positive or negative. And for cosine of theta, that's going to be x over square root of x squared plus y squared. And then for tangent of theta, that's going to be y over x. Now, important thing to note is that by squaring x and y, this number is always going to be a positive, even though x and y could be negative depending on what quadrant it's in. All right. Now, what about the other three? Well, they're just the reciprocals. So cosecant of theta is going to be square root of x squared plus y squared all over y. Secant of theta is going to be square root of x squared plus y squared all over x. And cotangent of theta is going to be x over y. Now for this fourth example, it seems like we're just applying the rule we just set down, and we are. So there's really no need to draw a picture. I can just follow the rules that were set up here. So let's see. Sine of theta is going to be, let's see, the y value, which is negative 2, all over the square root of x squared, which is 0 squared is 0, plus y squared, negative 2 squared is 4. So let's simplify that. That's going to be negative 2 over square root of 4, which is negative 2 over 2, which is negative 1. All right. So 2 is what we get anytime we're talking about the distance between the origin and this point, which makes sense. The origin is at 0, 0, so you just move down two places. So what is cosine of theta? Well, cosine of theta is the x value, which is 0 over 2, or more simply, 0. Then for tangent, what we get is negative 2 over 0. So really, when we have a number that's divided by 0, we write that that is undefined, because there's no way we can express what that means. So we just say that tangent is undefined. So for the other three, for cosecant of theta, we're going to take the reciprocal of negative 1. So 1 over negative 1 is still negative 1. So cosecant is the same as sine. Secant is the reciprocal of 0. So if we do 1 over 0, what happens? Same thing again. Secant is undefined. And it doesn't matter what's on the top, because both tangent and secant are undefined and we have different numerators. But the fact that we're dividing by 0, that is what makes it undefined. And that's going to be important in a second. So then finally, cotangent of theta, well, I can just take this fraction and just flip it and just have 0 over negative 2, which is 0. And so here we didn't really have to draw a picture. We could just apply the rules we set down. Sine involves the y value divided by the distance. Cosine is the x value divided by the distance. And then tangent is just the ratio of the y to x value. Now for number 5, we want to have, actually, that's not what it says on your worksheet. It actually says cosine. My apologies. And so it says find cosine if you know that sine of theta equals 3/7 and tangent of theta equals 0. Now the fact that sine of theta equals 3/7 tells us a lot of information. It tells us that this is the y value and that this is the distance from 0. So let's think about this. So we know that our point, that our coordinate, is going to be something, comma, 3. So what is that x value? Well, let's see. If I take the square root of x squared plus 3 squared, that's going to give me 7. All right, well, I can solve for x here, and that'll tell me what the x value could be. So if I square both sides, I get 49 over here. So x squared equals 40. So x equals square root of 40. Now the thing to remember is anytime you take the square root, you have to include plus or minus. And we can simplify that by saying, well, can't take the square root of 40, but we can take the square root of 4. And that square root of 4 is 2. And that leaves 10 inside the radical. So we have plus or minus 2 radical 10. Now the issue is anytime you deal with a problem like this is that x could be positive or negative, and we need a little more information in order to tell which one it is. Well, that's where this piece of information helps us. It says tangent of theta is greater than 0. Now what is tangent? Tangent is just y over x. And we know that y has to be 3. So whatever x is, if we take 3 divided by that, we should get a positive number. So that tells us that if this is greater than 0, that means x has to be greater than 0. So that means our coordinate is 2 square root of 10. It has to be positive. So now, if we want cosine, then cosine of theta is the x value we found, 2 square root of 10 all over the distance, which we had up here with sine. It's 7. All right. Now with number 6, it says find cosine of theta if you know that secant of theta equals 3 and cotangent of theta is less than 0. Now if you stop and think about that, that question's actually easier than you want to admit because, wait a minute, secant and cosine are reciprocals. So we actually don't even need that. We can just say cosine of theta is 1/3. That's all we need. That's good enough. So with this last one, we know that we want to find cosine of theta if we know that cotangent of theta is undefined. That means that for this ratio, what are we doing? Well, we're taking square root of x squared. Actually, no, we're not taking that. That would be cosecant or secant. If we're taking cotangent of theta, that's x over y. And the fact that it's undefined means that we divide by 0. So that tells us something. That tells us that whatever our y value is, our y value has to equal 0. So our y coordinate has to be 0 no matter what. So the question is, what is x? Well, it tells us that secant of theta is less than 0. All right, well, that means the secant ratio is x squared plus y squared all over x. And we're saying this is less than 0. Now, I said before that this quantity is always going to be positive. So what's going to cause this whole thing to be negative? If x is negative. So that means x is less than 0. But that's all we know. All we know is that x is less than 0. Well, let's write out what cosine would be. Cosine of theta, we already said, equals x over the square root of x squared plus, well, wait a minute. We already know that y has to equal 0. So let's simplify that. We have x over square root of x squared. And so that's going to be, now anytime you take the square root of x squared, that's going to give you absolute value because that tells you that it's a positive. And so what do we have up here? We already said that x is negative. And we said here with absolute value that this is positive. But otherwise, they're the same distance from 0, it's just one is negative and one is positive. So that means this is -1. That's what cosine equals. Thanks for watching. If you like this video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.